Okay, let's unpack this. Imagine a coding agent boosting its performance by 17%. Actually, up to an incredible 53%.
Wow.
Yeah, and get this. It does it by editing its own code.
Its own code.
Exactly.
Right?
Down. Intrigued? You definitely should be.
Absolutely. What's really fascinating there, I think, isn't just the number, the performance jump itself, but how it happened.
Right.
The AI itself figuring out how to improve without a person stepping in. That's a pretty fundamental shift.
Totally agree. And that's exactly what we're diving into today. We've got this great research paper, a self-improving coding agent.
SICA, they nicknamed it.
SICA, yeah. Right. And it sort of says, forget all that constant human tweaking, trying to craft the perfect prompts. This paper looks at an AI that just gets better at its main job coding by working on itself.
Yeah. And for you listening today, especially if you're trying to keep up with the cutting edge stuff, this research is gold. It really presents a new way to think about building AI agents, specifically coding agents that are more powerful and, crucially, more autonomous.
Autonomous is the key word there.
Exactly. The researchers have basically built a system where that usual line between the AI doing the task and the AI improving itself, it just kind of vanishes.
Right. It's not two separate things anymore. It's all baked into the agent itself. Code and improve, same process.
That's the core idea we're going to explore. We'll unpack how this SICA agent works, what makes it different from earlier attempts at this kind of thing.
Like self-refinement or other methods.
Yeah, and also what the early results are telling us about, maybe, where AI development is heading. We'll try to pull out the big aha moments, the practical stuff, without getting too bogged down in the weeds.
Sounds good. So let's maybe kick things off by looking at the problem they were trying to solve. Like, what was wrong with the old way of building these coding agents?
Well, if you look at how AI agents were typically built, it involves a lot of human effort. We, the humans, we're the designers, right?
Right. Setting up the architecture, figuring out the prompts.
Exactly. Crafting those prompting strategies to get the best performance. The paper mentions things you've probably heard of, like chain of thought.
Yeah, guiding the AI step by step.
And self-refinement, where the AI critiques its own work, or different ways to let agents use tools.
So lots of manual design, lots of experimentation, trial and error.
Precisely. And the thing is, even with all that effort, these human-designed approaches might actually miss better solutions.
How so?
Well, our own biases, our own limitations, they can restrict what we even think of trying,
Yeah.
So it leads to this big question. Could the agents themselves figure out better ways to operate?
Could they discover strategies we haven't even thought of?
Exactly. Can they find more optimal ways to work?
And that's where SICA comes in, I guess.
Yeah.
That's their answer.
That's the idea, SICA, the self-improving coding agent. The really core innovation is that it gets rid of that separation between the improver agent, the meta agent,
right,
and the doer agent, the target agent doing the coding. SICA is just one single agent.
One agent?
One agent that has the ability to directly edit its own source code.
Whoa, okay, so it's not just changing settings or prompts, it's literally rewriting its own programming. That feels pretty radical.
It is. And the whole point of this self-editing is to, well, improve its scores on coding tests, obviously, but also to use less computing power, cost less, and solve problems faster, and critically, do all of that on its own, autonomously.
Okay. Now, you mentioned earlier work. The paper talks about AD's automated design of agentic systems. How is SICA different from that?
Right. ADS, that was definitely an earlier step in this direction, automating agent improvement.
Yeah.
But it still had that separation.
The meta agent and target agent.
Exactly. ADS used a separate meta agent to optimize the prompts for a target agent. And importantly, that meta agent could only tweak things within a very limited specific language defined by the researchers. SICA, though, is aiming for true self-improvement. No separate meta agent calling the shots. And it works on its entire Python code base. The scope for change is just much, much wider.
Okay, so ADS was maybe like a mechanic tweaking a few knobs on the engine, whereas SICA is like the car learning how to redesign and rebuild its entire engine itself.
That's a really good analogy, yeah. And the researchers make this key point. Coding agents are kind of the natural place to start with this self-improvement idea.
Why is that?
Because they're built out of code. Code is something the agent itself can understand, analyze, edit. It's much more tractable than trying to self-improve, say, the weights of a neural network directly, at least for now.
That makes a lot of sense. Okay, so how does it actually work, the self-editing loop? What's the mechanism?
They call it the meta-agent loop. Basically, Sika keeps a history and archive of all its past selves, Agent 0, Agent 1, Agent 2, and so on. And for each past agent, it also keeps track of how well it did on the coding benchmarks.
So it keeps its own report card for every version it's ever been, like a performance history.
Exactly like that. So in each new improvement cycle, Sika looks back at this archive. It finds the version of itself that performed the best overall so far.
The current champion?
Right, the champion agent, and that one gets designated as the meta agent for this round.
Okay, so the top performer gets to try and make the next version even better.
Precisely. This chosen meta agent then analyzes the whole archive, the code from past attempts, the benchmark results, looking for clues like what works, what didn't, where could things be better.
Digging through its own history for insights.
Yep, and based on that analysis, the meta agent does the crucial thing. It edits its own code to try and implement those improvements.
Its own code? Wow, so it's not like testing changes on a copy, it's modifying itself directly.
Exactly. Then once the edits are done, this new, hopefully improved agent gets tested on the benchmarks again.
And the results go back into the archive.
Back into the archive, scores recorded, and the whole cycle starts over.
It's this continuous loop, yeah. Self-improvement driven by the AI. Okay, but how does it decide what's best? It can't just be about getting the highest score, can it? There must be other factors.
That's a really sharp point. No, it's not just score. They defined a utility function for this.
A utility function?
Yeah, basically a formula to decide the best agent. And it balances the benchmark score with how long the agent took and how much it cost to run. They actually measured cost in dollars.
Oh, okay. So efficiency matters too, speed and cost.
Definitely. They even gave specific weights. Score counts for half, 0.5, and cost and time each count for a quarter, 0.25.
50, 25, 25. Got it.
And they put caps on things too, like max $10 per problem, max 300 seconds. If an agent goes over, its utility score gets penalized.
That makes sense. Keeps it practical. You don't want an amazing agent that takes days and costs a fortune to run one task.
Exactly. It forces the improvement process to consider efficiency, not just raw capability.
Right. So when Sika started this journey, Agent 0, what could it already do? What was its starting toolkit?
Yeah, Agent 0 wasn't like a blank slate. It was already a pretty decent coding agent. It had tools for basic file operations, opening, closing, and importantly, overwriting files, which it needs to edit itself. It could run shell commands, had a simple calculator, could submit its final answers.
Standard coding agent stuff.
Pretty standard, yeah. It also had ways to manage what they called sub-agents.
Sub-agents?
Yeah, Sika uses a modular approach.
Yeah.
It has different specialized agents, like one just for coding, one for planning or problem solving, one for reasoning. The main agent can call on these.
Ah, like little specialist helpers.
Kind of. And these sub-agents can return results back to the main one. And crucially, for the self-improvement part, it had that archive analysis tool, the thing that lets it look back at its past performance.
That seems essential. It needs to learn from its history. You mentioned the sub-agents helping.
Yeah.
How do they fit into the bigger picture?
They serve a couple of key roles. First, they let the benchmarks run completely automatically. The main agent can farm out parts of a problem to the right sub-agent.
Makes sense. Division of labor.
Right. And second, it helps deal with context length limits in the underlying language models.
Ah, the attention span issue.
Exactly. Once a sub-agent finishes and gives its result back, the main agent doesn't need to keep all the details of that subtask in its immediate memory, its context window. So it helps it manage complex, long-running processes like the self-improvement loop.
Clever. Okay, the paper also mentions an asynchronous overseer. That sounds important. Maybe like a safety thing?
It is, yeah. It's a really interesting safety mechanism. It's basically another LLM running alongside the main Sika agent.
In the background.
In the background, yeah. Continuously watching what Sika is doing in real time. It's looking for problems like, is it stuck in a loop? Is it going way off track? Things like that.
So like an independent monitor keeping an eye on the self-improving process.
That's a good way to put it. If the overseer spots trouble, it can actually send a message to the running agent, like a warning or a suggestion.
Nudge it back on track.
Yeah. And in serious cases, if the agent seems totally lost or doing something counterproductive, the overseer can even step in and stop its execution.
Wow, it can pull the plug.
It has that authority.
Okay.
And it has a really broad view. It sees the whole call graph of how agents are interacting, the message history, the tools used, so it can spot patterns or wasted effort.
That sounds like a vital safety net, especially for something that's rewriting itself. Okay, so the big question. What happened when they actually ran Sika? Did it work? Did it improve?
Yes, it did. They tested it on several different benchmarks. There was a subset of SWE Bench Verified.
Real-world software tasks.
Yep. And LiveCodeBench, which more like competitive programming problems. Plus, they made 2 synthetic benchmarks just to test specific skills like file editing and understanding code bases.
Okay, a range of challenges. And the results.
Pretty significant improvements, yeah. Across the board, really. On that SWE Bench subset, the performance gains were between 17% and, like we said at the start, up to 53%.
53%, just from the AI teaching itself. That's really something.
It really is. And the synthetic benchmarks also showed clear upward trends as Szummer went through more improvement cycles.
The outline mentions a figure 3 in the paper visualizing this.
Yeah, figure 3 shows that utility scored the one balancing performance, cost, and time going up over the iterations. And what's cool is they marked on the graph when Szummer introduced specific new capabilities it invented for itself.
How neat. Like what kind of improvements did it come up with on its own?
Well, one of the first things was a smart edit tool.
Yeah.
See, initially it could only overwrite whole files, which is clunky.
Right, inefficient.
So it built this tool to be smarter about how it edited files, choosing better strategies. Then it made a quick overwrite tool, which is apparently faster in some cases. And later, it made the smart editor even better by using diffs.
Diffs, like tracking the specific changes.
Exactly, showing just the lines that changed. That allows for much more precise editing. It's fascinating how it improved. It didn't just get better answers, it improved its process. It learned better ways to handle files. That's meta-learning.
So it went from blunt instrument file editing to surgical precision.
Pretty much. It also developed a code context summarizer, better understanding of relevant code, and this really clever AST symbol locator.
AST, abstract syntax tree.
Yeah. So instead of just searching for text strings in the code, it learned to parse the code's actual grammatical structure, the AST.
Ah, so it understands the code's logic better.
Much better. It allows for way more accurate navigation and modification, especially in languages like Python. Think of it like having a building's blueprint instead of just a street address.
Huge difference.
Yeah. And later, it even combined that AST approach with a fast text search tool, ripgrep, to create a hybrid symbol locator. Super robust. You can see all the numbers in Table 1 accuracy going up, cost and time often going down, and this percent cached metric increasing, which means it was getting better at reusing information efficiently.
It's like watching evolution happen, but for code tools. Amazing.
Okay, but what about tasks that aren't just coding? The outline mentions reasoning tasks. How did Szummer do there? Ah, right. That's where the results were a bit different, more nuanced. They tested it on things like AMY math problems and GPQA Diamond, which are heavy on logical reasoning. And on those benchmarks, the improvements were, well, much smaller. Not nearly the big jumps they saw in coding.
That's interesting. Any idea why? Why great at improving coding but not reasoning?
The researchers suggest it might be down to the underlying models they used. For reasoning, they used this model called O3 Mini, which is apparently already very, very good at those kinds of tasks.
So the base model was already near peak performance.
Potentially. The agent framework, all the Szummer stuff around tools and self-editing, which adds so much value for complex coding tasks. It might not add as much, or it could maybe even get in the way slightly, when the base model is already a top-tier reasoner.
So it's like if you've got Albert Einstein, giving him a fancy calculator might not actually speed him up much for theoretical physics. He's already got the core ability.
That's a decent analogy, yeah. It really highlights how the agent system and the base model capabilities need to work together. The games depend on where the bottlenecks are.
Right. The framework helps where the framework can help. Makes sense. Okay, let's think about safety. An AI that rewrites itself, that sounds like something you'd want to be careful with.
Absolutely. And the paper definitely stresses the importance of safety for these kinds of self-improving systems. They built in a couple of key mechanisms.
Like the overseer.
The overseer is one big part of it, yeah.
Yeah.
But they also emphasize just good old observability.
Being able to see what it's doing.
Exactly. They build tools like an interactive web UI that let humans watch the agent's internal state, its chain of thought, the tools it's using, the actions it's taking. Transparency is key.
So humans can monitor it closely.
Right. And the second mechanism is iterative evaluation. The idea is that you can include safety checks within the benchmark suite itself.
Ah, so before a new improved agent is allowed to become the meta agent for the next round.
It has to pass not just performance tests, but safety tests too.
Build safety into the improvement cycle itself.
Exactly. They do note that their current system doesn't update the underlying model weights, which adds a layer of safety. but they acknowledge that more research is definitely needed for systems that do modify their core models.
That seems prudent. Okay, but bringing this all together then, what are the main things you think our listeners should take away from this SWE research?
Well, the biggest thing, I think, is seeing a concrete proof of concept. An AI agent that can genuinely improve its own coding skills by editing itself. That's a major step.
Yeah, it feels less theoretical now.
Right, and it points towards AI systems becoming more autonomous, potentially needing less hand-holding and manual design from us in the future.
Which could speed things up considerably.
Potentially, yeah. Also, that contrast between the coding result and the reasoning result is important. It tells us that how you design the agent framework really needs to mesh well with what the base AI model is good at. It's not one size fits all.
And safety aspect, the built-in monitoring and evaluation.
Definitely. It shows the researchers are thinking about the risks, which is crucial as these systems get more powerful.
Okay, now for that surprising or intriguing detail, what was the coolest self-improvement SWE made, in your opinion?
For me, personally, it's got to be that AST symbol locator.
The code structure tool.
Yeah. The fact that it figured out on its own that understanding the grammatical structure of code was better than just searching text, that feels like a real leap in understanding. And that it led to broad performance gains. That's impressive. It's not just pattern matching, it's grasping semantics.
That is pretty cool. Shows a deeper kind of learning. So thinking bigger picture, relevance, application, where does this go? Is it just coding?
Well, coding is the start, right? Because code is easy for AI to manipulate. But you have to wonder, could we see self-improving agents tackling other complex problems?
Like what?
Scientific research, drug discovery, maybe even complex financial modeling or business strategy. Anywhere you have complex processes that could potentially be optimized. You could really change software development itself. AI not just writing code, but constantly refining and maintaining it too.
The AI becomes its own architect, developer, and maintenance team, constantly iterating.
Good. And that leads us to the final sort of provocative thought. What are the limits here?
Yeah.
If an AI can rewrite its own code, could it eventually rewrite its fundamental architecture? Could it redesign itself in ways we can't even imagine right now?
That's a mind-bending question.
Right.
Where does self-improvement stop? What are the ethical lines as AI becomes more self-directed?
Exactly. These are the huge questions that research like SWE brings to the forefront. It's moving from AI as purely a tool towards something potentially more autonomous in its own development path. Fascinating. And maybe a little unsettling too.
Definitely food for thought. Well, if you listening are technically inclined and want to see the nuts and bolts, the paper mentions a GitHub repo you can check out.
Yeah, and the full paper's on ArcSIF too for all the details.
Great stuff. Thanks for breaking that down for us. Really fascinating research.